Today we're going to do a review of exponent rules. So just a reminder, if we had like x to the 5th power, that means we really have 5 x's. So the first rule that we're going to apply is, is when we're multiplying things. So for example, if we have a to the 3rd times a to the 4th. So remembering that this equals a times a times a times a times a times a. So this really equals a to the 7th. So the generic rule is if we have a to the n times a to the m, what do we do with those exponents is we add them. So an example of a more complex problem like this would be, let's say we had negative 10 x to the 5th y squared times negative 3x to the 4th, y to the 4th. So we're just multiplying everything. So the first thing we can do is we can multiply our number. So negative 10 times negative 3 is 30. And then if we take a look at our x's here, we have x to the 5th and x to the 4th. And again, we could always write that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's really 9 x's, so this would be x to the 9th. And then if we were to take our y's, we have y squared and y to the 4th, and we could do that same thing with it. 2 y's, 1, 2, 3, 4 y's, and we have y to the 6th. So when you are multiplying exponents with the same base, you are really adding those powers. Now the second rule we're going to look at, let's say we have a to the 3rd to the 4th power. Well, what does that really mean? We have a to the 3rd, a to the 3rd, a to the 3rd, a to the 3rd. We have it 4 times. And again, if I was to write this out, a, that is really a to the 12th. So what is our rule if there's a power? A to the 3rd to the 4th power, or let's write it with just some variables. So if we have a to the m, n to the m power, what is our rule when there's parentheses? We multiply those together. So a more complex problem on this might look like, let's say we had negative 3x to the 3rd, y to the 4th squared. So when it's outside the parentheses, we multiply, and we have to raise everything to that power. So negative 3 squared, negative 3 times negative 3 is 9. And then it would be x to the 6th, y to the 8th in our simplified form. The third thing that we are going to take a look at is when we divide powers. So for example, if I had a to the 5th over a squared. Well, this is really 1, 2, 3, 4, 5, 1, 2. So that's really a cubed. So our rule would be if we had a to the n over a to the m, we subtract those. So let's say we had, let's take a look at a more complicated problem. Let's say we had 5 over 125, x to the 7th, x to the 8th, y to the 8th, y to the 5th. So again, we can first look here at this, to simplify this first part here. 5 and 125. What does that simplify down to? Well, they're both divisible by 5, so this would be 1 over, well, what is 125 divided by 5? Well, that's 25. So 1 over 25, and then we can take a look here. Here's our x's, and again, we subtract them. 7 minus 8 is negative 1, but when you think about this, if I was to write this out, just like we did before, if I had 7 x's on top, 1, 2, 3, 4, 5, 6, 7, and 8 on the bottom, I could cross out 7 from the top, 7 from the bottom, and I'm left with 1 on the bottom. And then when we look at our y values, there's 8 on top and 5 on the bottom. So there's more on top, and there's 3 more on top. All right, so let's see. What is our rule for negative exponents? So if you remember a to the negative n, to make it positive, that's 1 over the n. Because, for example, like if you remember, like think about what we did above. If we had a to the third over a to the fifth, that would be 1 over a squared. But our rule was to subtract 3 minus 5. So that's a to the negative 2. So we flip that. All right, and that's our rule there. So we're just going to look at a more complex one. So if we had x to the 7th, y to the negative 5th, x to the 4th, y to the negative 1. I always look at this x to the 7th. That's positive, so that's going to stay. If I look at this next one, y to the negative 5th, it's a negative exponent, so I'm going to flip what side of the fractions it's on. X to the 4th, 4 is positive, so it stays. Y to the negative 1 is negative, so I flip it. And then we can simplify what we've done before. So there's more x's on top, so that simplifies to x to the 3rd on top. Look at our y's, there's more on the bottom, 4 more, so y to the 4th on the bottom. And then we're going to take a look at a problem where we put everything all together. And we might take a look, maybe we'll take a look at 2 of these. So let's say we have, I can't remember what problem, I wasn't numbering these, I apologize. If we have 15p to the 7th over 3p cubed squared. So let's get rid of our parentheses first. So 3p to the 7th, we multiply. So that would be 9p to the 6th. And now if we simplify 15 over 9, they're both divisible by 3. So 5 over 3, and where there are more p's on top, would be with a p on the top. All right, and let's take a look at one more like that. So let's say we have 5k to the 5th cubed over 5k to the 6th. So we distribute first. So 5 times 5 is 25. Times 5 again is 125. So 5 cubed is 125. K to the 15th over 5k to the 6th. All right, well, 125 over 5 is 25. And where are there more k's on top? And there's 9. So it would just be 25k to the 9th.